All right, so today we are on lesson 59, which is experimental probability. Can somebody tell me what probability is? What does probability mean? Eliza? Chance, okay. What I need to let you know today is there are two types of probability. Theoretical probability is when you analyze a situation and you make a kind of a guess based on what you think it's going to be. You look at the information. It usually happens before any experiment. So if I had a coin and I said, what is a theoretical probability of me tossing and it landing on heads? Alex?
1/2.
1/2. That in theory, half. Experimental probability is after the experiment. If I toss a coin 10 times and it lands on heads 6 times, what is the experimental probability of it landing on heads? It would be 6 out of 10, okay? Or 0.6. Do you understand? Because experimental probability is based on an experiment. So it's the number of times an event occurs over the total number of trials. So if I toss a coin 10 times and 6 times it lands on heads, the experimental probability of it landing on heads is going to be 6 out of 10. Theoretical probability is 5 out of 10. Does everybody see the difference? Taylor?
Can you reduce that?
Yes, you would definitely reduce. Definitely reduce. Now, what do you think is going to happen the more times I do an experiment? What do you think the probability is going to become more like? What I'm trying to say is, if I toss it 10 times and I get 6 out of 10 on heads, what do you think is going to happen if I toss it 100 times or 1,000 times or 1,000,000 times? Any ideas?
You're always going to get 1/2.
It's not always, but it's going to be closer and closer. So the more trials I have, the closer the experimental probability will come to the theoretical probability. So the more I toss a coin, the more accurate my experimental probability is going to be. Does that make sense? If I wanted to know the favorite radio station of 7th and 8th graders, and I just asked this class, would that be a good sample size?
No.
Kind of small. If I want to know all 7th and 8th graders in the whole world, their favorite radio station, their favorite type of music, and if I just ask 22 of you, that's not a very big sample size. But if I would have to, the more I ask, the closer I'm going to get to the real probability. It's the same situation here with theoretical and experimental probability. The more times I do an experiment, the closer I am going to be to the theoretical probability. Okay, so you can kind of look at theoretical probability as before and experimental probability as after. Okay, let's look at example 1 on page 401. A softball player has 21 hits and 60 at-bats. Any softball players in here? Baseball players? Okay, are you trying out? Good, good. Okay, so Hannah at tryouts gets to bat 60 times and she makes 21 hits out of 60. What is the probability that when she goes up to bat the next time, she's going to get a hit? Based on experimental probability of a hit, how many times did she get a hit? 21. And what was the total number of tries? 60.
31.
And that equals 0.35. And in softball and baseball, as you probably know, they add a 0 here and they say, oh yeah, she has a 350 batting average. That's pretty darn good. 350, anything above 300 is pretty decent in the major leagues. So anyway, that is the experimental probability. So they use experimental probability a lot in sports. Let's look at, but they also use it in other situations too. Look at example 2 on page 402. A salesperson distributed samples at the mall. 50 shoppers accepted the samples and 30 did not. What is the probability that a shopper at the mall will accept the sample? So what is the probability of accepting the sample? Let's go back to this basic formula. How many times did they accept it? 50. And what was the total number of trials? 80, right? Because 30 times it did not. So in this case, you could say the probability that a shopper at the mall will accept the sample is 5/8. 5 out of 8 people accepted the sample. And again, we reduced it. Okay? How many of you guys find this to be pretty easy? Good, good. Don't make it too hard. Now, sometimes you have an experiment or you want to know something that is really impractical to do an experiment on. And so you'll want to do what we call a simulation. For example, if you look at example 3, the commuter plane flight arrives on schedule 2/3 of the time on any given weekday. Heather wants to know what the probability is that it will arrive on schedule on a Tuesday, Wednesday, and Thursday in the same week. So instead of going to the airport and waiting to make sure and see if this flight lands on time all 3 days, and again, she really can't just do this once. She probably needs to go back next week and the next week and the next week to get to have more accuracy. That doesn't really make sense if she knows it's on time 2/3 of the time. So what she did is she made a spinner and she simulates. So we know if it's on time 2/3 of the time, then she could simulate the spinner and say, okay, this is Tuesday's flight, and she spins it. This is Wednesday's flight. This is Thursday's flight. And if they landed on time all 3 times, then she can count, okay, that was a week where it landed on time all three days, okay? So she would just have, and then she could do that. That would be 1 week, and then she'd do 3 more spins for another week, 3 more spins for the next week. And so you can see how it's not, in the interest of time, there's a way you can simulate the experiment and not have to actually do it. All right, so that is basically it. If you stick to this formula, you shouldn't have a problem with the problems that you have. Okay, so your homework is A through E, 1 through 30 odds and check.
Remember, you do.